So in the previous class, we talked about the depreciation analysis, and we talked about the definition of depreciation and different terminologies associated with depreciation and the types of depreciation. This is what I just wanted to emphasize. Types of depreciation is different from methods of depreciation. Generally, both are three numbers in this lecture, but whenever sometimes when I ask method of depreciation, people start writing types, and I ask types, and people swap the answer. So whenever I ask types of depreciation, there are three types. One is called physical depreciation, functional depreciation, and contingent depreciation. Whereas methods are three. I didn't list them. The first is the straight line method, and next is called constant percentage method, and third is the sinking fund method. So we'll be discussing about this with an example problem also. So it will be easy for you to understand, right? The first is straight line method. It's pretty easiest method. In fact, this is what generally used in most of the cases. The reason for its implementation or using is its commonality is it's simple. It's very straightforward, and it does not have much mathematical calculations involved. Whereas the other two methods need some calculations and some mathematical components, but this is simple arithmetic, so probably it's easy for everybody to do it, right? So what is in this method is we will be finding annual depreciation. Remember that depreciation is generally an annual stuff, like it's calculated annually. So that's why we have annual depreciation, or generally a depreciation capital D equals to original cost. What is the cost which you paid for that item initially, minus a scrap value. What is your anticipated scrap value, divided by the number of years it gets used. So that's what basically a depreciation. If the number of life it's very small, then the depreciation is gonna be pretty high. So that's how you sell something in 3 years have got a huge depreciation than the one that's planned to sell for more than 10 years or something like that. So that's basically the depreciation. Then it's very important thing is called book value. So book value is what exactly a ledger value, or this is an accounting terminology which tells about the worth of the equipment or the property or something like that. So this is a typical formula, but we can convert that into a tabular column so we can understand much better. Say for example, this is life in year, year 0, which means that at that moment when you buy something, say for example, if I buy something now this April, or May 1st I buy something, 2022 May, it will have a depreciation. So it will have a value of depreciation. Otherwise it's gonna be pretty new. But then people generally say even if you sell before that, that kind of depreciation you have to really consider. But generally yearly depreciation is what we consider. So that's why for the first year there's no depreciation, and the C0, which is a book value at year 0, is equals to the C, which is the original cost. So that particular item does not have any depreciation. Then after 1 year, then you will be finding capital D. How do you find capital D? Is original cost minus scrap value divided by life in year. So that will be the value here. This value minus the original cost of the equipment or property, that will be the C1, the book value of the particular thing in year number 1. So do you understand? C0 or C minus D. So that's basically the depreciation thing somewhere. Then second year, you can even see the same D. There's no D plus something or D minus something, but the same D, the same value we'll be putting it here, and this minus this value, C1 value, not C0, C1 value, which is the first year book value, minus a depreciation will be the second year book value, and keep on going until nth year, this year, nth year. At the nth year, we'll have the same depreciation. The n minus 1 year minus the D will give something called Cn, which is the book value of the nth year. But that is surprisingly the SC, the scrap value. That should equal SC. If you get some other value, then something calculation mistakes are there. So generally it will be the scrap value which we anticipated initially, right? So at the end of the nth year, after depreciating all these things, you have to end up with the scrap value of the property, right? So that's basically the straight line method. This is predominantly used. Reason is that depreciation here is all constant. So this is a straight line. When you plot this, is probably a straight line. So that's how many people are really, interested in this kind of methodology. But the problem associated with that is you cannot have this D to be common for all the year. Sometimes in the initial stage, the depreciation might be less, but as the year progresses, say if this is N is 10 year, for the first 2 years, the depreciation might be small. It's not very, high. But when you go ninth year, eighth year, then the depreciation might be high. So that's you cannot have a D constant throughout. So that's why many people argue. Then they formulated another methodology called constant percentage method. So this is constant percentage method. So the constant percentage, you remember this is not depreciation, capital D. Remember, this is a very important thing. It's another factor called constant percentage, capital P equals to 1 minus scrap value divided by original value, and the whole power is 1 by n. Generally people makes whole power n. That's very wrong. It's 1 by n. So it's a formula to calculate the constant percentage, right? So once we find the constant percentage, 1 minus constant percentage will be finding out. So we also find P, then 1 minus P, then 1 minus P into original cost will be the book value. Remember, in the previous case, we find the depreciation, then we find book value. So how do we do that? As original cost minus the D will be the book value of that year. In this case, we'll find P that will be constant. The constant percentage will be constant throughout. Then we'll find 1 minus P, then 1 minus P power X. X is the year. If it is 0, first 0th year, it's 0, first year, it's 1, and so on. Then multiplied by original cost will be book value. So we'll be putting it here, book value, right? And then we'll find depreciation, capital D. So which means that original cost minus the book value. So instead of working from depreciation to book value, we'll find book value to depreciation. So which means that our focus will be the variable depreciation. So depreciation is not constant in here. So that's a basic logic of the constant percentage method. So let's take a look at it. So C0, the book value at 0. In the previous case, we talked about depreciation to book value. In this case, we'll be finding out book value to depreciation. So C0 is the initial or the book value of the year 0. It's nothing but here the original cost C multiplied by 1 minus P. 1 minus P power 0. Remember, this is x is 0 to n. So at the year 0 it is 0. So 1 minus P power 0 is 1. So C into 1 is C. So it will be the original cost. So in the first 0th year it will be original cost. So the logic is clear. Here also the first thing will be the original cost. There's no depreciation for the year 0. But this is 0 to 1 means 1 year. The one this like when you buy a property, this will be at that moment and after 1 year, something like that. And this is we don't find depreciation directly, but instead we will find C1, which is the book value. So which is nothing but original cost multiplied by 1 minus P power 1. Reason is that the year is 1. So X is 1. So 1 minus P is 1. Then we'll find depreciation, which is nothing but the previous year book value minus the current year book value will be the depreciation for that particular year. Let's go to C2. C2 is original cost multiplied by 1 minus P the whole power 2. Reason for 2 is that it's second year. Then that value the previous value book value minus that value will be the depreciation of that particular year. And the same logic applies, and when you go till n, C into 1 minus P the whole power n will be generally the scrap value. So this is a typical example of constant percentage method, right? So before we get into sinking fund method, let's take a look at the different methodologies in a graphical form, and this is a typical example. Straight line will give this a book value versus the year 0 to n. Straight line method will give initially the original cost, and it goes on and on and on, and finally it ends up with the scrap value. Constant percentage method, initially the depreciation is pretty much lesser, or something like the book value is it's kind of a sloping curve, and finally it reaches the scrap value. But sinking fund, on the other hand, it's just like an incremental curve, and finally it looks into it, it ends up in the scrap value. So these three are very, very important things. So probably you can take a look at that in greater detail or something like that. So this is how sinking fund sinking fund method will be doing a little later. And first we'll take a look at this example. Application of depreciation analysis on construction equipment, right? So the reason why we study depreciation is to incorporate in the construction management stuff. And this example is on concrete mixture, predominantly used construction equipment for concrete construction. And say concrete mixture was purchased as 80,000 rupee. Salvage value was without being dismantled, or it is scrap value. Um, then it is 10,000 rupee after 5 years. So the salvage value of the 80,000 items after 5 years, n is equal to 5 years, is 10,000 rupee. Calculate the depreciation for each year. So if I want to sell this 80,000 equipment after 5 years, it will be 10,000 rupees. So what are the depreciation? If I want to sell it in first year, second year, what will be the price of the concrete mixture? So that's a basic logic, right? The straight line method, constant percentage method, we'll be looking at in a much detail. In a straight line method, the formula is original cost, which is 80,000, minus the scrap value or salvage value, which is 10,000, divided by 5. So which means that 80,000 minus 10,000, which is 70,000, divided by 5 is 14,000. So this is a constant value, and depreciation is constant throughout. So probably you can calculate the depreciation here. And very importantly, in a straight line method, we'll be finding depreciation first, then we'll end up with the book value. Say, can you take a look at this? Probably it's self-explanatory. The first is 80,000 minus 7,000 divided by 5 is 1,000 minus 7 10,000. I think probably we can do that in Excel. Probably you can try it in Excel. And book value is that first is the original cost. Original cost minus the the depreciation value is equals to the book value of the year. So 80,000, you can even do it in a calculator. 80,000 minus 14,000. If you press it, 66,000. Then you again minus another uh, 14,000, or you can even give 14,000 into 2, it will be 52,000. Then you minus 14,000 into that 3, it will become 38,000. And finally, when I give 80,000 minus 14,000 multiplied by 5 will be 10,000, which is equals to the salvage value. Remember that 80,000 minus 14,000 is 66,000. Then the 66,000 minus 14,000 is 52,000. 52,000 minus 14,000 is 38,000. 38 minus 14 is 24. 24 minus 14 is 10, which is the scrap value, right? So this is a simple method, and you can see that the depreciation is constant throughout the life of the particular equipment. Let's take a look at the constant percentage method. So this is a little trivial. So the constant percentage equals to 1 minus scrap value divided by the original cost power 1 by n. Remember that it is P equals to 1 minus scrap value is 10,000, original cost is 80,000, n is 5, so 1 by 5, power 1 by 5, which is nothing but 0.34. So 10,000 divided by or we can even say 1 minus 10,000 divided by 80,000. This is power. Yeah, just put. Yeah, yes. Finally, we got it. 0.34. But I just round it up to 2 decimal places. for simplicity in calculation. But if you can do it in Excel, you don't have to really round off, so it can automatically take the final decimal, right? So once you find p, we have to find 1 minus p, which is nothing but 1 minus 0.34, which is 0.66. So this is what very important in calculation. Remember, sometimes people multiply c into p power x, but that's wrong. It is c into 1 minus p power x. Okay, so that will be the value. Then finally, in a constant percentage method, we'll be finding out the book value. Book value is equals to original cost multiplied by 1 minus p the whole power x, which is nothing but, in this case is the original value 80,000. In the next case, the book value, which is nothing but 80,000 multiplied by, what is 1 minus p? It's 0.64. 0.64. Then I think power um, something like 1, right? So it's 0.64. Yeah, it's 52,800. So 52,800. So 80,000 minus 52,800 will be the depreciation. You see that depreciation is high at the initial stage and it gradually decreases at the final stage. At the initial stage itself, if you want to sell, you will have to compromise this huge value. But once the machines gets used for a longer period of time, the depreciation of that is pretty less. So this is actually decreasing in terms of the book value also. So for a 10,000, the 5,000 is a depreciation, and for 15,000, 7,000 is depreciation. It's almost 60% or 50% something. So that's how we calculate the depreciation here, right? So in constant percentage method. Now we'll go to the sinking fund method. So this is a little confusing. Just kindly pay attention to it. It will be a little difficult to understand. The reason is that this is purely the financial management stuff. So it involves the interest and also the rate of interest and something like that. Say the sinking fund method, the depreciation assumed to be annual sinking fund plus the interest of the accumulated sinking fund till the year. So which means the depreciation is considered as annual sinking fund as some amount plus the interest accumulated till that year. It is not that year, it's till that year. So this is very important. So far in all the examples, we'll be considering that particular year what is the depreciation. But in a sinking fund, it looks into the accumulation of the fund from the previous year also. So let's take a look at what exactly that means. So the total amount of sinking fund, capital S, equals to original cost minus the scrap value, right? So remember, this is not depreciation. This is the total sinking fund, capital S, and this is not original cost. Sinking fund equals to original cost minus the scrap value. Annual sinking fund, capital I, which is nothing but coefficient of sinking fund, IC, multiplied by total amount of sinking fund S. So this value, right? So the coefficient of sinking fund IC, this IC equals to, I is a rate of interest. Generally rate of interest in decimals. We don't provide it in terms of percentage. If it is 6, the value will for I will become 0.06 divided by 1 plus I the whole power n minus 1 equals to x. So which means that annual sinking fund is equals to IC into S. So which means that S into IC. IC is nothing but I divided by 1 plus I the whole power n minus 1. Then this is very important. So this is the accumulated amount till that year. So amount of rupees 1 per annum in M years, the rate of the sinking fund, I mean the accumulated sinking fund IS equals to the ulta of this 1 plus I the whole power m. Instead of n, it is m, because that particular year it will vary if m ranges from 0 to n, minus 1 divided by I, this equals to y. Here we will be finding out the rate of depreciation. Rate of depreciation is nothing but x multiplied by y. That will be in terms of percentage, right? I equals to rate of this is small I, this is a correction required, not capital I, small I, which is equals to rate of interest. We will be generally putting it in decimals. Actually, this will be very difficult to understand. So I have created a formula kind of thing, which is nothing but I interest first we'll be finding an annual sinking fund, which is capital I. This coefficient of sinking fund multiplied by the total sinking fund, we'll find total sinking fund, right? Then we'll find interest on sinking fund, II. So II will be, interest on sinking fund will be this for a particular year. So which is nothing but I, the annual sinking fund, multiplied by ISM, which is nothing but that accumulated amount at mth year, minus m year, that particular year, multiplied by I, which is nothing but the interest on sinking fund, total annual sinking fund, minus is of this till the previous year. So this is little difficult to understand. So once you find this, depreciation is nothing but I plus II. So this will become this, and finally book value will be the original value, and similarly C minus this minus this will be this, and this minus D1 will be this, and so on, and finally we'll be ending up the scrap value or something like that. Finally, the book value will be original investment minus the depreciation of the time or year past, which means that previous depreciation, right? So it will be very difficult to understand that with the PowerPoint presentation. Then I've just made it in a form of an Excel sheet, so you can understand it very clearly, which is nothing but original cost of equipment, which is C. There's no formula involved, just 80,000. That's given. The problem, the concrete mixture is 80,000. Then number of years, N, it is 5 years. So we only have to find out, no, understand that it's for 5 years. And scrap or salvage value after 5 years is 10,000 rupee, and this is given. And rate of interest, it is given as 6%. So generally the rate of interest is given as 6%. We don't put it in terms of percentage, but instead it is 0.06. So the value is 0.06. And finally coefficient of spelling mistake, coefficient of sinking fund, IC, which is nothing but I divided by 1 plus I the whole power n minus 1. So which means that I, the rate of interest, it is 0.06. You remember it is E5 plus E5. Okay. So it is nothing but 0.06 divided by 1 plus 0.06, the whole power E3 is nothing, 2 decimal places, so it will become 0.18. So that's basically the IC, right? Then this is pretty simple, capital S, which is nothing but original value minus the scrap value. So 80,000 minus 10,000 is 70,000. 70,000 multiplied by 0.18, that will become the annual sinking fund. So annual sinking fund for the in this case, very interesting thing is we have to do -1. So which means that the year, even though it has not much implications, but we will be putting it -1, which means that 0th year and before the 0th year. So this is age in, you can even call this -1, but does not makes much significance. Here you can call 0, something like that, or you can even call, this is just a serial number, right? So all right, so this is very interesting thing, and the generally will start other processes here, but you can still start the other processes, but no, this is the logic, basic logic. And remember that this is the 0th year, annual sinking fund also will become 0, and amount of that rupees accumulation is also 0, and interest on sinking fund will be 0, depreciation will be 0, but the book value will be the original cost, so the 80,000, right? So this will be from the input E2, which is 80,000, right? And finally for the first year, we'll calculate the annual sinking fund. So we calculate the annual sinking I equals to 12,418, and this is constant throughout. So the annual sinking fund amount that's get, can even talk about this. This particular amount is what we save to for 80,000 stuff, right? Something like that. Then this is very important thing. So the amount on rupees 1 accumulation is that. So in the previous thing, it's E5, which is nothing but interest on sinking fund in terms of decimals. So 1 plus interest on decimals. Then B5, so which is nothing but B5. This is year. That's power year. Divided by input E5, which is nothing but the the interest value in terms of decimal places. Then that will become 1, and this gets varied as the year changes. Only thing is, like if you can see in Excel, only the output gets varied, the year gets varied. Remember, all other things are same. So we'll have this amount, accumulation amount of 1 rupee per annum in M years from era. Then interest on sinking fund. So this is very important. This is where I have given the formula. We have got all these things are from this thing itself, like C5, which is nothing but this value, annual sinking fund, minus D5, which is the amount accumulated till that year. Multiplication of this two, minus B5, which is the year, multiplied by C5, which is nothing but the annual sinking fund. So remember the formula. I'll just share the formula, so it'll be easy for you to understand. So you cannot find this formula in any textbook, because the reason is that they'll be doing it by word calculations, by descriptive. So I made it like a formula. This is the formula I have made on my own. So that's how this particular formula I have put it in Excel here, and finally we'll have something like this. You can even, it's e power minus 10. It's very small value, so it's almost 0. So that's why the depreciation is this, and this will become this one only. So then I plus probably can, did you see this thing? Yeah. So then finally the depreciation is nothing but the book value minus the previous depreciation will be that depreciation. So I'll change that. It will be little confusing, but if you practice, it will not have much implications, right? And this will become G4 minus F5. So which means that G4 is this minus F5. So this one will become the depreciation of this, and this minus this will become this, and finally this minus this will become this, and this is 10,000, which is the scrap value. So whatever the problem to check you have to do, one is the initial value should be the original cost, and final thing should be the scrap value. So that's how you have to calculate it.